Welcome to Azelinguistics. This channel is about all things linguistic, discussing topics in phonetics, phonology, morphology, syntax, semantics, and sociolinguistics. So let's see what we've got today. So what are we doing today? I'm going to show what a distributional statement is. We have talked about distribution of sounds. Sometimes you have a data set and then you're going to look at the way the different sounds, the different phones are distributed, and you're going to figure out if they're different phonemes or they are allophones of the same phoneme. So as I said earlier, complementary distribution is the distribution of the allophones of a phoneme in different environments that are mutually exclusive, such that if allophone A of phoneme X appears in environment 1, allophone B never appears in the same environment. So allophone B would appear in environment 2 or 3, but not environment 1. To know exactly what this means, you can go back to the video that we did about complementary distribution. I want to do this using a particular example, which is going to be a data set from a particular language, which in this case happens to be Korean. The way I've organized the words and the data is also going to facilitate the analysis, because the particular order, the fact that they're arranged in 2 columns, every column is consistently following a particular pattern. Okay, so the sounds sh and sa. So this is a sound sh and this is a sound sa. So when you're given a data set, well, it could be different situations in which you're tackling a data set for phonological analysis. You might have a data set, you might start looking at the data set from different approaches, and you might find different things in the data set. But in this case, we have clear instructions to only look at these 2 sounds in the data set. How do we start the analysis? This is my way of approaching the data. I personally recommend when you have a data set like this and then you want to analyze the data, you can actually do something that makes your life easier. I'm going to number the data. So I have put the numbers in like gray. So now I can make clear references to those words. I can say, oh, word 1, word 2, word 3. The first question you need to ask is, do you find any minimal pair here? There's no minimal pair. You cannot find 2 words which are similar in everything except for the same sound in one position. So there's no minimal pair. Okay. Now that you don't have any minimal pair, the next step is look at the sounds in question, which is s and sh, and list the environments in which they occur. The first thing you do is you put them on top. So we are creating 2 columns. Then you start on the left. So in the word sun, the sound se appears in the beginning of the word. It means before the sound, there is the starting word boundary. In the location of the actual sound, you put it like an underscore, and then it is followed by O. So what I do is I usually write the number, the word number next to it, because then when you want to follow up and check your work, you can easily do this. Like you say, oh, this environment, it happens in word number 1. Then I move on to the second word. In this word, there's 2 instances of the sound sa. So the first one is, again, is so. So the first one is again like this. So instead of listing that environment, I just add number 2 here. Then you have the second occurrence of sa, which is preceded by this, and then followed by the schwa, right? And this happens in word number 2 again. Because there's 2 instances of sa, the word number 2 has been listed in 2 different environments, and so on and so forth. So you have listed all the environments. Now you ask the next question. For the sound sa and sha, do you see any environment under sa that you also see under sha? If there is no similar environments, it means that this is a case of complementary distribution. If it's a case of complementary distribution, then you have to be able to make a distributional statement about this. If the 2 sounds are complementary, if they're allophones of the same phoneme, then they appear in different environments, but those environments are rule-based. It means they are predictable based on a particular rule or particular rules. So these environments, like the environments for sa and the environments for sha, they are systematic and they're predictable. Then the question is, okay, how can you predict? To make something prediction means there is a rule. So here I have listed the sounds, as you see, conveniently listed with the proper word number. So as you see, it's a very small data set for just 4 words on the left, 4 words on the right, 5 different environments for sa, 3 different environments for sha, because although there are 4 words, but 2 of them provide a similar environment, which is words number 6 and 7, you have a same environment for sha. There must be at least one rule that explains when one or the other of these two appear. So there's something that these environments share. Do you see a pattern? As you accurately observed, the sha is always followed by e. The sa is never followed by e, okay? The sound sa appears in more environments, right? It can be followed by o, it can be followed by schwa, followed by a, followed by e. But the sound sha is followed only by e. So it is only in this limited one particular environment that the sound sha occurs. In all other environments, this occurs. So what are we going to do is we are going to write a rule here. There is a phoneme. Of course, we said it's a case of complementary distribution, in which case it means both sha and sa are allophones of the same phoneme. And the same phoneme, and this phoneme is sa because it appears in more environments. It becomes sha only when it's followed by e. In Korean, this is what happens. So that was the distributional statement, but you can write it in the form of a rule. So sa becomes sha whenever it is followed by e. When you state this rule, it means elsewhere this rule doesn't apply. So you just state when the rule applies. Now you can present this knowledge that you have about Korean in a different format, which is called derivation. This phoneme, when it's a phoneme, it's not pronounced, becomes this allophone. So the phoneme is the underlying representation, UR, and the allophone is the surface representation. So it means at some deep level, it is sa, but when it surfaces, depending on the environment, it is affected by the environment. So in the abstract level, it is sa, but it becomes sha in certain environments. So in order to provide the diagram, what you have to do is you have to think of 2 words. Look at the word for hand. In this case, the rule does not apply because it is not followed by e. But if you look at the word for 50, the rule applies because it's followed by e. So I'm going to take these 2 words as examples. You can say these words have an underlying representation. So when you say underlying representation, you're talking about phonemes, right? The word 50 at the underlying level should not be oshib, it should be osip. Then something happens here that it becomes the surface representation. It becomes son, and this becomes oship, okay? There's something happening here. In order to know what happens, you can go back to the chart. Okay, you have the sound sa becoming sha. If look at this is the front of the mouth, this is the back. So if sa becomes sha, it is moving towards the palate, and the movement towards the palate is called palatalization. If you look at osip, it is becoming oship. So here it is being palatalized. There's something important here in terms of notation, in the sense that underlying representation is the phoneme, surface representation is a particular allophone. For allophones, we use square brackets. For phonemes, we use slashes. But for the rule level, we don't use any bracketing. It's a transition from slash to square bracket, and there's no bracket here. Thanks for your time and attention, and see you again soon.